Today, viewers all over the world. Today, we want to solve differential equations that involve initial value problem. That is, initial value problem on second order linear non-homogeneous differential equations. Okay, we can also solve it on homogeneous differential equations. Look at the question. We have to solve y prime prime minus y prime minus 2y is equal to exponential 3x. Of course, these are non-linear non-homogeneous differential equations, which we have actually used the two methods to solve in our past video. We have used the method of particular solution. So in this case now, there are two solutions. Y will be equal to yc plus yp. This is a complementary solution, and this is a particular solution. So we have solved this using the two methods. Now, when we want to find a particular solution, we can use method of comparing coefficient, or we can use the other method, particular integral. So in this case now, when we solve this, we have done this in the past. We found the value of y to be equal to the value of y is given as the general solution to this problem is given as c1 exponential ex plus c2 exponential 2x plus 1/4 exponential 3x. This is the general solution to this particular problem. How do we get the general solution? It's a non-linear, it's a linear non-homogeneous equation. You first equate the right hand side to the zero in order to get the particular solution, complementary solution. So once we find the complementary solution, then we go ahead. Once we know this complementary solution, we'll go ahead to find the particular solution. And if you want to find the particular solution, of course, we know what to do. There are two methods involved. Is that you use the method of variation of parameter or method of variation of parameter. We can use variation of parameter to get this, or comparing coefficient. So we have done this. If you check my past videos, I've used the two methods to solve this particular problem. This is what we have. So when we have initial value problem, that is when initial value problem simply means that we want to find the value of all the unknown C1 and C2. Because this solution that we have here is not the general solution. How do we get the specific solution to this problem? There's need for us to find this arbitrary constant C1 and C2. So if you want to do that, what do we do? For us to be able to find that, of course, when I introduce differential equations, we have actually talked about initial value problem and boundary value problem. And we are made to understand that under initial value problem, a differential equation along with subsidiary condition of the unknown function and its derivative are all given at the same value of independent variable. Look at y of x here. In this case now, x is equal to 0. X is equal to 0. And y prime of x is also equal to 0. They are given at the same independent variable. So this problem is problem under initial value problem. So what do? We just go ahead and look for y. What is y? Y is given as, what is y? Y is given as c1 exponential minus x plus c2 exponential 2x plus 1/4 exponential 3x. Okay, so what is y of 1? This y is the same thing as y of x. It's y of x. So when x goes to 0, y of 0 will now be, wherever you see x here, you change it to 0. So we are going to have c1 plus c2 plus 1/4. That's what we are going to get. Okay, that's what we are going to get. And it's equal to 1. It's equal to 1. So c1 plus c2 will now be equal to 1 minus 1/4. So c1 plus c2 will be equal to 3/4, equation 1. We have gotten the value of the first equation there. We have gotten the value of the first equation. Then, and of course, we've gotten the value of the first equation. And of course, I can multiply through. No, from here, I can try to multiply 2 by 4 so that I will have 4c1 plus 4c2 plus 4c2 equal to 3, equation 1. So I will go ahead and differentiate this. I want to look for y prime. Y prime of x will now be equal to, when I differentiate what I have here, when I differentiate this, I'm going to get minus C1 exponential minus x, then plus 2C2 exponential 2x, plus 3 all over 4 exponential 3x is equal to 2. That's what we're going to get at the second one. So when we substitute, when y equal to 0, I have y prime of 0 to be equal to, here will be minus C1 plus 2C2 plus 3 all over 4 is equal to 2. Then here we have minus C1 plus 2C2 to be equal to 2 minus 3 all over 4. Then here we are going to get 5 all over 4. So minus C1 plus 2C2 will be equal to 5 all over 4. Then minus C1, if I multiply 2 by 4, I will have minus 4C1 plus 8C2 is equal to 5, equation 2. That will give me equation 2. So equation 2 is given us what I have on the board. So there are two equations now, equation 1 and equation 2. So in order to find the value of C1 and C2, I'm going to solve the two equations simultaneously. So once I solve these two equations simultaneously, I will be able to get the value of C1 and C2. Once I know the value of C1 and C2, I'll substitute back to the general solution. Then that's going to give us the value to this initial value problem. When we introduced the differential equation, we said that once you substitute value of the arbitrary constant into that particular solution, then that gives the actual solution to the problem. Then differential equations plus subsidiary conditions, this plus these other conditions is actually will give us IVP. So C1 is 4C1 plus 4C2 is equal to 3, equation 1. The C2 is minus 4C1 plus 8C2 is equal to 5, equation 2. So how do we solve these two simultaneous equations? We can try to add the two equations together. So we say add equation 1 plus equation 2. If I add equation 1 plus equation 2, this will cancel out. I'm going to have 8 plus 4, that will be 12C2 here to be equal to 8. Then C2 will not be equal to 8 all over 12. That is what we are going to get there. So, and of course, C2 can be equal to 4 here to 4 here 3, C over 2 over 3. That is C2. So I will say substitute C2 equal to 2 over 3 into equation 1. If I do that here, I will have 4C1 plus 4. C2 is 2 over 3. 2 over 3 is equal to 3. So here I will get 4C1 to be equal to 3 minus 4 times 2, 8. That will be 8 all over 3. So 3 minus 8 all over 3. 3 minus 8 all over 3 will actually be 1 all over 3. So 4C1 will be equal to 1 all over 3. Then what is C1? What is C1? C1 will be equal to 1 all over 12. That will be C1. C1 will be equal to 1 all over 12. So finally now, y, which is same thing as C1 exponential minus x plus C2 exponential 2x plus 1 all over 4 exponential 3x. That is y. So once we substitute the value of y1 and y2, C1 and C2 back into this solution, then we have gotten the solution to this problem, the actual solution to this problem. So y will not be equal to, what is C1? 1 all over 12 exponential minus e plus C2, 2 all over 3 exponential 2x plus 1 all over 4 exponential 3x. So this will actually give us the solution, the actual solution to this particular problem. And that's what we have done, as we can see on the board. So let's look at another example. Let's look at another example that involves IVP. Okay, say example 2. Example 2. So example 2, we have to solve y prime prime minus y prime minus 2y is equal to 4x squared. So where y of 0 is equal to 1 and y prime of 0 is equal to 4. That's what we have. That's what we are given. So in this case also, it's the same thing. If we check our past video, we have been able to solve. We have solved for the value of that linear non-homogeneous equation. We got the value that involves C1 and C2. Of course, once we have gotten the value, then the only thing that required is for us to for us to find the value of C1 and C2. So if you check the past video, at least if you check 2 videos, you will see the solution to this non-linear non-homogeneous equation. So we have been able to find the solution to this. Y is equal to C1. The solution that we have got here, we have gotten like E minus X plus C2 E2X minus 2x squared plus 2x minus 3. This is the solution that we got when we solve this. When we solve this, this is the solution that we arrive at. Okay, so we don't want to go ahead and find the value of C1 and C2. Once we find the value of C1 and C2 and substitute back to this solution, then that will represent the actual solution to this problem. Okay, so y of 0, when we substitute, when x goes to 0, we have C1 plus C2 minus, here will be 0, 0, that will be minus 3, is equal to 1. So C1 plus C2 will be equal to 4, equation 1. So if I differentiate what I have here to have y prime of x, what would that give me? Minus C1 e minus x plus 2C2 e 2x minus 4x plus 2 is equal to, that's what you are going to get. Then when we now have y prime of 0, when it's equal to 0, I have minus C1 plus 2C2, here is 0, plus 2 is equal to 4. So we have minus C1 plus 2C2 to be equal to 4 minus 2, equation 2. So we have gotten the two values, equation 1 and equation 2. So we've gotten the two values. So once we know the two values now, what will now be the solution? Of course, if I had equation 1 and equation 2, say this is equation 1, C1 plus C2 is equal to 4, equation 1. Say equation 1 plus equation 2. What do we get? This will cancel out. We are going to have TC2 to be equal to 6. So C2 will be equal to 6 over 3, and that will be 2. Therefore, C2 is equal to 2. We've got the value of C2. So we just say substitute C2 equal to 2 into equation 1. So what is equation 1? C1 plus C2. C2 is equal to 2. Is equal to 4. So C1 is equal to 4 minus 2, and that's 2. So C1 is also equal to 2. So we realize that C1 is equal to 2, and C2 is also equal to 2. So C1 is equal to C2, and both, the value of both is actually equal to 2. So the solution to the IVP is y is equal to, what is C1? Is 2. That will be 2 exponential minus x plus, what is C2? Is also 2. 2 exponential 2x minus 2x squared plus 2x minus 3. So under initial value problem or boundary value problem, we'll be required to find the values of all the unknown, all the arbitrary constants here. And that's what we have found. So when we have differential equation plus subsidiary conditions, plus all these conditions, they are referred to either IVP, initial value problem, or boundary value problem. But these two examples that we have considered in this video, they are actually initial value problem. So we are going to continue from there in our next class. Thank you.